Hello children, today we are going to start next topic in the first chapter, the language of chemistry, and that is chemical equations. A chemical equation is the symbolic representation of a chemical reaction using the symbols and formulae of the substances. And a balanced equation is a chemical equation which has an equal number of atoms of each element on both sides of the equation. For example, when calcium carbonate is heated, it decomposes to produce calcium oxide and carbon dioxide. In this equation, the number of atoms on each side are: left hand side calcium 1, carbon 1, oxygen 3, right hand side calcium 1, carbon 1, and oxygen is 2 plus 1, 3. So the equation is balanced. Now we are going to use hit and trial method for balancing. We'll count the number of times, that is frequency an element occurs on either side. The element with the least frequency of occurrence is balanced first. When two or more elements have the same frequency, we'll give preference to the metallic element. Now we are going to learn how to balance chemical equations. As you can see here, sodium hydroxide reacts with sulfuric acid to give sodium sulfate and water. So I have written in the form of equation. You can see here NaOH for sodium hydroxide, S2SO4 for sulfuric acid, Na2SO4 for sodium sulfate, and S2O for water. Now I see that sodium has the least frequency. So in order to balance, on the left hand side I multiply NaOH by 2. So the number of sodium atom becomes equalized. Then what is observed? Sulfur is 1 on both the sides. But hydrogen on the left hand side, 2 plus 2, 4. That's why what did I do? I multiplied this water molecule by 2. Then oxygen, 4 plus 2, 6. Here 4 plus 2, 6. It is already balanced. And after balancing, we can put the sign of equality. Similarly, we'll go through other equations as well. Potassium bicarbonate plus sulfuric acid gives potassium sulfate plus carbon dioxide plus water. Now, with what will we start first? We'll start with potassium. Here you can see 2 and here only 1. So in order to balance it, we multiply potassium bicarbonate KHCO3 by 2. Now, after multiplying, what do we see is that K2SO4 plus CO2 plus H2O. So now what do we see is that carbon on the left hand side it becomes 2, but right hand side it is still 1. So let us make it 2 by multiplying by 2. Okay, now sulfur on both sides are equal. Now let's see hydrogen atoms. 2 plus 2, 4. And here it is only 2. So we need to multiply it by 2 in order to make it 4. Left hand side oxygen atom, 3 2s are 6 plus 4, 10. And on the right hand side 4 plus 2 2s are 4, 8 plus 2, 10. Hence we can put the sign of equality. Next example, Fe plus S2SO4 gives FeSO4 plus hydrogen. So here what do we see? Iron on both the sides it is 1, sulfur is also 1, hydrogen 2 and oxygen 4. So the equation is already balanced. Simply what we'll do? We will replace the sign of arrow with the sign of equality, which proves that the equation is balanced. following the law of conservation of mass, which says that mass can neither be created nor be destroyed. Next is chlorine plus sulfur dioxide plus water gives H2SO4 plus HCl. So, as we can see, here chlorine, number of chlorine atoms are 2, and on the right hand side it is 1. Okay, so we'll start with balancing of chlorine. So Cl2 plus SO2 remains as such, H2O remains as such, which gives H2SO4 plus HCl. So here we multiply it by 2. Now on multiplying it by 2, the number of chlorine atoms are balanced. Now left hand side sulfur 1, right hand side also sulfur 1. Now left hand side hydrogen is 2, but right hand side 2 plus 2, 4. So we need to multiply this water molecule by 2. Now oxygen left hand side 2 plus 2, 4, and right hand side also 4. Therefore the equation is balanced, and hence we can put the sign of equality. Next one, silver nitrate AgNO3 gives Ag plus NO2 plus O2. Now silver both sides it is 1, nitrogen 1, but oxygen this side it is 3 and the other side it is 4. So what is the least number with which we can multiply this odd number to make it even? That is 2. So let us multiply by 2 and see. 2 AgNO3 gives 2 Ag plus 2 NO2, because here already nitrogen becomes 2, plus oxygen. So now silver is balanced, nitrogen is also balanced. 2 3s are 6, 2 2s are 4, plus 2 6. It is balanced. So we can replace the sign of the sign of arrow by the sign of equality. Next one is copper reacts with nitric acid to give copper nitrate, nitrogen monoxide and water molecule. So what do we see is that the frequency of nitrogen is 1, 2 and 3. Copper it is 2, but it is already balanced. Oxygen it is 3. This side the frequency of oxygen is 1, 2, 3, 4. 4 times. And the frequency of hydrogen is 1 and 2. Okay. So let's start with balancing of hydrogen, because it has the least frequency. So how are we going to balance? At least we need to put 2 out here in order to balance. But if I put 2 here, the number of nitrogen will be 2. But here we can see already the number of nitrogen is 2 plus 1, 3. So that means we will take the next higher number, that is even number, that is 4. If I take 4 out here, okay, we can put 4 here. So in that case, we need to put 4 here also. So let's try by putting 4. So Cu plus 4HNO3 gives copper nitrate NO3 whole 2 plus NO plus H2O. So since 4 is here, 2 and 2. Is it balanced? No, it is not balanced. So let's see about hydrogen. Okay, let's multiply by 2. Then let's see about oxygen. 4 3s are 12. And this side 3 2s are 6, 7, 8, 9, 10. So the equation is not balanced. So similarly we can try with other numbers. So let's try with 8. Suppose we take 8 HNO3. Now, in that case, see, number of nitrogen atoms are 8. We can do one more thing. We can also increase the number of nitrogen atoms out here. It is not necessary that we'll increase there only. So, let's increase the number of nitrogen atoms out here. Suppose if we multiply by 3. So here the number of nitrogen atoms become 3 2s are 6 and 2 remains out here. Now what do we see? Copper is 3, so we put here 3. Hydrogen is 8, so we can make it 8. 4 2s are 8. And oxygen 8 3s are 24, so 3 2s are 6, 6 3s are 18, 19 20 plus 4 24. So the equation is balanced and hence we can put the sign of equality. Next example is of ammonia reacting with oxygen to give nitric oxide and water. So nitrogen both sides it is 1. Hydrogen here you see 3 but there it is 2. So what shall we do? We shall try to make it an even number. Okay, what is the least number with which we can multiply? It is 2. So if we multiply by 2, what do we get? 2NH3 plus O2 gives NO plus H2O. So we need to multiply this by 2. Now the number of nitrogen atoms are equal and 2 3s are 6 hydrogen atoms. So we can make out here 6. No? 3 2s are 6. But what happens to the number of oxygen atom? 3 plus 2, 5, which is an odd number. That means this will not work. The equation is not balanced. So let's start by multiplying with the next even number, which is 4, and see how the equation goes. So this side we can put 4NO plus H2O. 4 3s are 12. So we shall put out here 6. Then let's see hydrogen. 4 3s are 12. Oxygen it is 2 and on right hand side it is 6 plus 4, 10. How to make it 10? If we multiply oxygen by 5 it becomes 10. We can put the sign of equality. Hence the equation is